Okay, good morning, everybody. So we're just, let me just remind you what we were doing last class. We were talking about implementing a list. In this case, we're using an array. So I was showing you what happens when you insert or remove from the middle of an array. So I just want to quickly remind you that when you insert into an array, you end up having to move, right? So if I want to insert an element at position 4, I have to move the elements at index 4 and to the right. I have to move them one position to the right. When you move them in Java, one way to do it is to start moving from the end, right? So you move the end element over one, then you come over and you move the second last element over one, and then the third last element over one, and so on and so on and so forth. Right? You can't start moving from here, because if I move this one over one, I overwrite an existing element. Right? So when you're moving to the right, you start from the end of the list. Right? So I shift them over. That makes room for the element to insert, and then you just insert the element here. Right? Let me skip over this. Okay, so if I want to remove the element at index 4, you're going to move the elements in red one position to the left. Right? So you're going to start at position 5, and you're going to move the element to the left. Right? You're not going to start from the end, because if you move the end element over one to the left, you overwrite an existing element. Right? So after moving the elements one to the left, right, you just overwrite the element that you want to remove. Right? So 5 into 4, 6 into 5, 7 into 6, and so on and so on. Right? All right, so from these pictures, you can tell that inserting and removing from a list in general is going to be in big O of n. Right? You may have to move up to n minus 1 elements when you remove. Right? So if I remove the first element, I have to move the remaining n minus 1. I have to move the remaining n minus 1 elements to the left. Right? And if you insert at the front, right? So if I insert at the front, I have to move the current n elements over one to the right. Right? So these, both of these operations, when you use an array to implement a list, they have complexity big O n. Right. Now, can we do better than big O n? Well, sometimes. Where's the slide? All right, so let's finish off the array-based list, and then we'll start with the linked node-based list. Okay, so what's the array list look like? So I'm going to call it S array list, and it's going to implement S list, right? So I'm using the S to indicate this is a simplified array list, and S list is the simplified list, right? Mostly to distinguish it from Java's list and array list, right? Because they have a richer interface than the one we're going to implement. Now the implementation of the array list looks a lot like an array-based queue or an array-based stack, right? You're going to have an array of objects to hold the objects, right? To hold the elements, sorry. You'll keep the size you'll keep the number of elements as the field called size, right? In the constructor, you just make the array and set the size to 0, right? So nothing really different there compared to an array or stack. Right? The size method, you simply return the size, right? Because you're storing that as a field anyway. Add is similar to the adding to or pushing an element onto a stack. Right? So remember, when you push an element onto an array-based stack, you add it at the end. Right? Sometimes you have to resize the array. Right? So if the number of elements in the list is equal to the length of the array, right? You have to resize the array to make room for the extra elements. Right? Remember, when you resize, you always resize by a factor of the current array length, right? Where that factor is bigger than 1. Once you resize the array, you just set the you set the element at this dot size, right, in the array, and then you increase the size by 1. Right? So adding an element is pretty straightforward, but this step right here, right, the copy of, that's potentially in big O of n. Okay, next I'm going to write a little method that checks the index to make sure that an index is valid when someone uses it. I need to do this because we're going to implement remove at an index. And we're going to implement a method that gets an element at a particular index. Right, so both of those operations, you have to check that the index is valid before you try to access the array element. Right, so I don't want to repeat myself, so I'm going to write a little private method here that checks the index. Right, it just makes sure that it just checks if the index is less than 0 or if it's greater than or equal to the size. Right, and in either case, it throws an exception. Right, otherwise it does nothing. Okay, now get. So get should return an element at a particular index. Right? So first thing I do is I check the index to make sure it's valid. Right? Next thing I do, I go into the array, right? And I get the element at that index. Right? Now remember, our array is an array of object. In a generic list, I need to return an array of the element type E. Right? So I have to cast the object reference to the reference of type E. Set's pretty similar. No, I want to set an element or replace an element at that index with that value. Right? So elem is the replacement value. Now, in this method, you also want to validate the index, right? But you want to validate the index and you want to return the element that is being overwritten, right? So the original the element that's currently sitting at position index. Right? Well, I can get the element at position index using get. Right? And furthermore, the get method checks the index. So the get method will validate the index for me. So I don't have to do, or I don't have to call check index here. Right? By calling get, I get check index anyway. Right? So that's kind of cute. Right? When you get the element at that index, that gives you the old value or the current value of the element sitting at position index. Right? Now you just go ahead and replace the element. Right? So you set the element in the array at that index, and then you return the original value. Right? So that's also pretty straightforward. Adding. So this one, adding an element at a particular index. So this is insertion into the list at some index. Right? Now remember, when you insert into a list, it's a little bit funny because that index there, right? It has to be greater than or equal to 0, right? So it has to be, so it can't be negative. But when you insert into a list, the index can be equal to the current size of the list, right? Which indicates you want to insert at the end of the list. Now that's a little bit different than the other methods that use an index, right? So here in get, right, the index has to be greater than or equal to 0, but less than the size of the list. Right? Same with set, and same with remove. Right? Here, the index is allowed to be up to the size of the list. Right? So I can't use check index right away. Right? Because if I use check index and I pass in the size of the list, it will throw an exception incorrectly. Right? So the first thing I do is I check. Is the index equal to the size of the list? And if it is, I just call the add method because it does the same thing. Right? Now I want to add at the end of the list. Right? And then I return. So in other words, I don't do the rest of the method. Right? So I immediately return. Once I look at that case, I can then call check index to see if the index is valid or not. Right? Because now it has to be between 0 and the size minus 1. Right? So if I get past check index, I know that the index is valid, right? So I have to move. So this is inserting, right? So I have to move elements to the right, right? And I have to move all the elements starting from index onwards, right? So from index up to size minus 1. Right? Now if I'm moving to the right, I have to start at the end of the list, right? So I'm going to start, right, my index I at the end of the list. So that's going to be the size minus 1. Right? I want the loop to run as long as I is greater than or equal to the index, right? Because I want to move the element at the insertion index. And of course, this loop's going to count down. Right? So now I'm going to move elements to the right of I. Right? So I is the index of the element to move. Right? So I'm going to move it to the right. So moving to the right means setting the element at I plus 1. Right, and I'm just going to set it to whatever was in the element at index I. Whatever was in the array at index I. Right? There's a little question mark, can this throw? Right? So can this throw? Let's see. I plus 1. So the largest value of I plus 1 is this dot size. Right? So it's this dot size. So can this throw? Well, maybe. Let's come back to this in a second. So let's assume I am able to move everything over to the right by 1. Right? I'm able to move everything. So once I move everything, I take the element to insert, right? And I set the element at that index to the element to insert, and then I increase the size by 1. Right? There is an error in this method. Right? So number 1, can that thing throw? So can that thing throw? Right? So can it throw? Right? Remember, it could be equal to this size, right? I plus 1 can be equal to this dot size. So can that thing throw? Right? So I guess the question asked is this dot size a valid index for the array? The answer is no, right? It's not a valid index for the array, right? You have to be careful here. There's actually 2 errors. There's another error. Does anybody see what the other error is? There's a second error in here. Remember, your add is inserting an extra element into the array. Right? So there's something that we're not checking for here. Anybody got it? So what's the first thing we checked for when we implemented add? Right? Is there space? Right? Is there space in the array for the new element? Because I want to add an element to the list. Right? If the array is full, I can't add an element to the list, right? So I have to resize. Inserting into the list is the same thing, right? If the array is full, I have to resize. Right? And nowhere in this method, except possibly up here, right? Except possibly up here, does this method actually check if the array needs to be resized, right? So that's what's missing, right? That's what's missing. Now, if you have to resize, right? So if you have to resize, I just want to, right? So if you resize, then that can't throw, right? So then it can't throw. Because if you resize, then the capacity of the array is bigger than the size, is bigger than the current size, right? So in other words, it has to be at least size plus 1. The capacity has to be at least size plus 1. So using an index of this dot size is fine, right? But there's actually 2 bugs here. One, we're not checking for the resize condition, and 2, that thing there might throw an exception. Right? At least I think it might throw an exception. Yeah, it'll throw an exception, right? So if you try to insert into this array plus 1, this size, but will it throw an exception? No, that won't throw an exception in this case, because hang on, just a second here. So if the array is full, you're going to resize, right? So once you resize the array, that will no longer throw. All right. So the array, yeah, okay, that's good. All right, so what about remove? Now remove is the method where we want to move elements to the left by 1 position and overwrite the element at that index. Right, so I also want to return the element at that index, right? So I want to return the old element, I want to return the element that I'm about to remove from the list, right? So I can get that element using the get method, right? Remember, get checks the index, so I don't have to manually check the index here myself, right? So that's nice, right? So I don't have to repeat any validation code here. Now I want to move elements from the right to the left, right? So I want to move the elements at indexes index plus 1, index plus 2, index plus 3, up to size minus 1, 1 position to the left, right? So starting at index plus 1, right? Going up to, but not equal to the size right? The number of elements in the list, right? I want to move the element at index I one position to the left, right? So that's the element at I minus 1, right? So can that throw, right? So can that throw? Well, so what's the smallest index that I can pass in is 0, right? Smallest element. That means I is at least 1, right? So is 1 minus 1 a valid index? The answer is yes, right? So the index 0 is a valid index. So that can't throw, right? Can this throw? Index plus 1, right? Index plus 1. So what's the valid index? So the valid indexes are up to the size minus 1, right? Up to the size minus 1. So size minus 1, right? Plus 1, right, is size, right? So if I is the size, this loop doesn't run, right? Because the loop only runs when I is less than the size, right? So that thing there on the right, the thing on the right-hand side will never cause an exception either. So this, in this case, this statement will never cause an exception, right? The last thing you want to do, remember I'm moving elements over to the right, but I'm not actually moving them, right? All I'm doing is making an array assignment. Right? So whatever's sitting at the end of the list, right? The last element in the list, it's not being actually set to anything, right? I take the element at the, I look at the array position where the last element is, and I copy that value 1 to the left, right? So whatever's sitting in that last position is still there, right? So I should null out whatever was sitting in that last position, right? Now, if you don't null it out, right, there's actually not an error, right? There's no logical error here, right? Your list will still work just fine. The problem is if you don't null out that element, the array has a reference to some object, right? Because it's not, you didn't set it to null, right? So you imagine you add a bunch of stuff to a list and then you remove everything, right? The elements that you remove, there are still references to those elements sitting in the array. Right? If you never use the, in the array. If you never use the list for anything, right, those references are still kicking around, right? Which means the garbage collector can't remove those elements from memory. So if you don't null out that element, you have a potential memory leak. Finally, once you've moved all the elements to the left, you can decrease the size of the list by 1 and then return the element that you got from up here. Right? So you return the element that you overwrote. Okay, any questions about the add or remove methods, right? Everything else is more or less the same as stack or queue, right? Printing a list is the same as printing a stack or queue. Equals is more or less the same as equals for a stack or queue if you try to implement it, right? They're all the other methods are more or less the same. All right, so the other thing we have to do is we have to implement Iterator now. Right? So we want to provide a list where someone can iterate over the elements. So someone can write for each element in this simple array list, right? Do something with the element. Now to do that, let's back up here. Hopefully I put it in. Oh, I didn't. Yes, implements slist. So remember, slist also extends the iterator interface, right? So anything that implements slist must also provide the iterator method. Slist implements the iterable interface. So it has to provide an iterator method, right? So there's our method that returns an iterator, right? So it's going to return this new array iterator. Now, as the implementer of the slist class, we have to implement the array iterator class as well, right? So if you, I think I'm going to review this in a minute next. Yeah. Okay. So way back in lecture 20, so 10 lectures ago, when I first started talking about interfaces, I showed you how to implement an iterator. Right? Right? So first of all, remember what an iterator is. Right? So an iterator is an object that knows how to iterate over a collection of elements or a sequence of values. Right? So a list iterator is going to be an element that knows how to start. Normally you'd start at the beginning of the list, and it knows how to look at each or visit each element in the list. the big reason for using iterators is the for each loop, right? So when you write the loop that says for each element in blah, right, you're actually using an iterator object, right? You may not know that you're using an iterator object because the compiler is generating the iterator for you, right? So it hides the creation of the iterator and the use of the iterator from you, right? But that's actually what's happening underneath the hood. Second reason for using an iterator is that it's actually the only guaranteed safe way to iterate over a list or set and remove elements while you're iterating, right? And you should go back and review the list and set notebooks in part 1 of the notes if you haven't seen that before, or if you're unfamiliar with what that's talking about. I think there's an example later on in this lecture as well. Okay, so 10 lectures ago when we implemented Iterator, we only implemented 2 methods. We had hasNext and we had next, right? Now remember, if you have an iterator and you call hasNext on the iterator, it returns true if there's still elements to visit in the collection, and it returns false otherwise, right? Calling next on an iterator returns the next element in the iteration, right? Unless there aren't any, in which case it throws an exception. For a list, we also want to implement the remove method that belongs in the iterator class. So remove, in the iterator interface, right, remove is a default method, right? So by default, it throws unsupported operation exception, right? So if you don't override remove, you can't use the iterator to try to remove an element, right? It immediately throws an exception. Right. Now I want to override remove because I want someone to be able to use an iterator to remove elements from the list. Right. So we're going to override this guy. Right. There's one more default method that's not shown here, and we're not going to override that one today. It uses features of the language that we don't talk about in this course. So remove for an iterator should remove the element that was most recently returned by next. Right, so the way that you use the iterator is you call next repeatedly, right? After you call next once, right, you're allowed to call remove once, right? So every time you call next, you're allowed to call remove once, right? So you can do next, then remove, and then next, and then remove, and then next, and then remove, right? You can't do next, remove, remove, right? That's not allowed. Right? So if you try to do that, so if you try to call next and then remove twice, you should get an illegal state exception. Right? So in other words, you can't use an iterator to remove, you have to use the iterator to remove the element that was last returned by next. Right? If you haven't called next yet, you also get an illegal state exception, right? Because there hasn't been an element returned by next yet, so there's nothing to remove. Iterating over a collection and removing elements as you iterate is called filtering, right? So if I want to remove all the negative values from a list or set of integers, you can write the following code. Right? So you make an iterator, right, by calling the collections iterator method, right? That returns something of type iterator, right? Now this is a list or set of integers, so it returns an iterator over integers, right? You call hasNext for the loop update condition. Right? So remember, that's true if there's still an element if there's at least one more element to visit in the collection, and false otherwise. Right? There's no update here. Right? That's a bit weird. Right? Normally in our for loops, there's an update condition here, or an update statement. Instead, the update statement, when you're filtering, is inside the loop. Right? So iter next will move the iterator to the next element. Right? This only runs when hasNext returns true. So this will never throw an exception in here. Right? So when you call next, you get the next element in the set or list. Right? So that's an integer value in this case. Right? I'm doing filtering of values that are negative. So if the value is less than 0, I can just call remove using the iterator. Right? I can't call remove again inside the loop. Right? At least not without calling next again. Right? So for each call to next, you're allowed one call to remove. Right? So that's the standard way of filtering a list or set. Okay, so what exactly is an iterator, or how should you think about an iterator if you want to implement one? Right? So if you have a text editor, right? So Eclipse, for example, right? Or the text editor in Eclipse, right? It has a cursor, right? So that flashing line, right? Which is right there, right? So in a text editor, a cursor sits between letters, right? So if you imagine that the letters are elements of a collection, then the iterator is the cursor, right? So an iterator sits between elements, right? So that red thing in the picture, that's my iterator. Right? So this is an iterator for a list that's between the elements at index 7 and 8. Right? So there's element 7, there's the element at index 7, there's the element at index 8. Right? The cursor sits between them. Or sorry, the iterator sits between them. Right? Now, I'm going to refer to the number 7 as previous. Right? And I'm going to refer to the number 8 as next. Right? So previous is the index of the element, right, that was last returned by the iterator's next method. The next index, that's the index of the element that will be returned by the iterator when you call next. Right? So previous, that's the element that was previously returned by next. And next, that's the index of the element that will be returned by next. Okay? So if I call next with this red iterator here, right, it's going to return the 6. Right? And it will move the iterator 1 to the right. Right? So it's just going to move over to sit between the 6 and the 10, like that. Right? So return 6, and now your iterator moves 1 position to the right. Right? So now previous is 8, right? Because we returned the 6, right? And next will be 9, right? If you're at the end of the list, right? So this list has 15 elements in it, right? 1, 2, 3, up to 15, right? So when the iterator gets passed, the last element that's in the list has next will return false. Right? And if you try to call next with this iterator, right, it should throw an exception because there's no more elements to iterate over. Okay? And at the beginning of an iteration, right, so when you first create an iterator, it should be positioned at the front of the list. Right? So at the front of the list, it's sitting before element 0. Right? Which means previous is -1 or some other negative value, whatever you want to use. Right? So previous is -1. Next will be the index 0. All right, any questions so far? Everybody got that straight? Okay, so previous, the element is the index of the element that was last returned by next, or -1, right, if no element has been returned by next yet. Right? Next is going to be the index of the element that will be returned by the iterator when you call next. Okay, so inside my sArrayList class, the array iterator class lives. Right? And that class must implement the iterator interface. Right? Now, if you remember back 10 lectures, right, the iterator class is a nested inner class or just inner class. Right? So remember, there's a second type of class. Right? There's a static, there's a static nested class. Right? Now, this class is not declared static, so it's not one of those. Right? Instead, it's an inner class. Remember what an inner class object is allowed to do. Right? So it's allowed to access the members of its enclosing object. Right? So in this case, if I have an array iterator object, it's allowed to access the fields of its enclosing sArrayList object. Right? So the array iterator class is allowed to go out into the sArrayList class and call any of its methods or use any of its fields, even the private ones. Right? So that means array iterator has access to the size of the list. Right? It has access to all of its methods. It has access to the array if it wants it. Right? So that's what you get when you use an inner class. Now, the inner class, you use an inner class as something that helps the enclosing class, right? So the only purpose of the inner class is to help the outer class do something, right? So the outer class needs to return an iterator, right? So it makes sense to make this an inner class, right? No one else needs to make an array iterator, right? The only class that needs to make an array iterator is the sArrayList class. So it doesn't make sense to make this a top level class. Right, so here are our two fields for array iterator, right? We have next and we got previous. Next is the index of the element returned by the subsequent call to next, right? So when you call next, you're going to return the element in the array at that index, right? Previous is the index of the element returned by the most recent call to next, right? And we set it to -1 if an element is removed when you call remove. Right? So remember, the value of -1, that indicates that either next hasn't been, either at the beginning of the iteration, right? So you haven't called next yet, or every time you call remove, you're going to set previous to -1. You'll see why in a moment. Right? Okay, so the constructor should set the iterator at the front of the collection, right? So that means next should be 0, right? And previous should be -1. Right? Has next is easy, right? How do you know that there's another element in the iteration, right? Well, remember next, that's the next element that you're going to, that's the index of the next element you're going to return, right? So it has to be a valid index, right? If it's not a valid index, has next is going to return false, right? How do you know if next is a valid index? Well, it has to be less than the size of the array list. Notice that the iterator class is allowed to go out and look at the field called size, right? It does it in a weird way, right? So remember, this syntax is funny, right? So for the inner class to access an outer class field, right, it uses the name of the outer class, followed by .this, followed by the name of the field, right? So that's just the way that the Java language does it. It looks strange, but that's just the way it is. Okay, next. So next should throw an exception if there are no more elements, right, to visit, right? I can check if there's no more elements to visit by calling hasNext, right? So if not hasNext, right, throw an exception. The standard exception to throw is no such element exception, right? So that's what the iterator interface says an iterator should throw if there are no more elements to iterate over. Okay, so what am I returning? So remember, this .next is the index of the element to return, right? How do I get the element at that index? Well, I can just call get, right? So again, using that strange syntax, right? sArrayList.this.get, right? Calls the get method in the list, right? Now that's slightly inefficient because get checks if the index is valid. Right? But you already know that the index is valid because hasNext returned true, right? So slightly more efficient would be to write sArrayList this array this next, right? So in other words, the iterator can go straight into the array and get the element itself, right? So it doesn't have to call get; it can look in the array itself. So that's slightly more efficient, and is probably the way that the standard library version of ArrayList is implemented. Okay, what do you do next? Well, I have to shift the iterator over one position to the right, right? So what does that mean? That means both previous and next should go up by 1, right? So next goes up by 1. Now remember, previous, that's the index of the element that was most recently returned by next. So that's going to be this .next, right? And then you return the element that you get from the array. Right? So there's your next method. Any questions so far? Remove. All right, so remove is, it turns out is also very straightforward. It's very easy to implement. You just have to pay attention to the details. Right? So here's my iterator. So it's sitting between elements The previous element is 8. The next element is 9, right, at index 9. Right, so the most recent element returned by next was the 6, right? So when I call remove on this iterator, I'm going to remove the element at index 6, right? So if you want to think about it as, you can think about it as backspacing if you're thinking about this as a cursor, right? I'm going to backspace and delete the 6, right? Now, remember what next should return for this iterator, right? For this iterator, next should return the value 10, right? So it should return the value 10. So keep that in mind, right? So calling remove is supposed to remove the 6, right? The last element returned by next, right? That's easy to do, right? How do I remove an element from the list? Well, I just call remove, right, on the list. Do I know what index to remove? Yeah, I want to remove the element at index 8, which is previous, right? That's stored in the value previous. So that's easy to do, right? I just call the remove method and pass in previous as the index to remove, right? Now, what happens when you remove the 6? Right? So remember what happens when you remove the 6? All of these elements here, right, they get shifted over to the left by 1. Right, so the 10 is going to come into here, the 4 will go where the 10 is, the 14 will go where the 4 is, and so on and so on. And your list looks like that. Right, so the 10 is now sitting where the 6 was. Right, the 4 is sitting where the 10 was, the 14 is sitting where the 4 was, and so on and so on. Right? The iterator hasn't moved yet because we haven't updated it yet. But notice what happens if you call next on that iterator, right? It was supposed to return 10, but if you call next on this iterator, it's going to return the 4, right? So you're going to miss something in the iteration, which is not good, right? So we have to update the iterator, right? But that's easy to fix, right? How do I update this iterator? Well, I just set next to be next minus 1, right? So I back next up by 1, right? Now if I back next up by 1, previous and next both point to the same index, which doesn't make any sense, right? Next is the next element to return. Previous was the element that was most recently returned, right? So it doesn't make sense that they both point to the same index, right? Now to resolve that problem, we just set previous equal to minus 1 to indicate that previous is no longer valid, right? That also gives us a way to determine whether or not you're trying to call remove twice during each call to next, right? Because you're not allowed to do that, right? So whenever I call remove, I'm going to set previous to minus 1, right? So what does that let us do? Well, if I check if previous is minus 1, right, that either means we haven't called next yet, or we've called next and then remove already, right? So if previous is minus 1, I throw an illegal state exception. Right? That's the exception that the remove method contract says I have to throw. Right? If I can remove something, then I just go ahead and remove the element at this dot previous. Right? Then I adjust the iterator. Right? So I move it back 1 position by subtracting by decrementing next. Right? And then I indicate that we've removed an element by setting previous to minus 1. And that's it. Right? So there's your iterator class. That's almost identical to the way that Java util ArrayList implements its iterator. Right? So now you know how to implement an iterator for an array-based list. Okay, that's actually it for an array-based list. Everything else you know how to do, right? So we've looked at array-based stacks and array-based queues, right? All of the methods there. So the methods are all similar, right? The way you do things are pretty similar. In a list, you've got a method that inserts into the middle and removes from the middle. So those are a little bit different. Right? We also have an iterator, so that's a little bit different. If you want to, you can add an iterator to the stack and queue classes, to the array-based stack and queue classes. Right? So if you want to, you can let people iterate over the elements of a stack or queue. Right? When you do that, you probably shouldn't implement remove. Because in a stack and queue, you're only supposed to be able to remove, well, from a stack, you only remove from the top. From a queue, you only remove from the front. Right? But you could give them an iterator to visit the elements if they wanted to, right? If you wanted to. And you now know how to do that. Or you can follow the example and adapt it to stack or queue. All right, now just like stack and queue, I now want to implement a list using nodes. Right? And so the type of list that I'm going to implement is what's called a singly linked list. Right? So a linked list is an implementation of a list that uses nodes. Right? So just like a linked stack or a linked queue. Right? Now in a list, the node at the front is given the name the head node. Right? The node at the back is given the name the tail node. Right? So the head of the list and the tail of the list. In a singly linked list, right, each node has a link to the next node in the sequence. Right? So that's how we implemented stack and queue. Right? But there's other types of linked lists. So there's a doubly linked list. Right? So in a doubly linked list, each node has links to the next and previous node in the sequence. Right? So with a linked list, it's easy to move from the front of the list to the back. Right? You just follow the next links. Right? In a doubly linked list, you can move in either direction. Right? So you can move forward by following the next link, and you can move backwards by following the previous links. Right? Now, obviously, the difference between these two is that the doubly linked list needs more memory. Right? Because now each node has to store an extra link. Right? So you use up 1/3 more memory. Right? Because in a doubly linked list, your node will have a next link, a previous link, and a reference to the element. Right? In a singly linked list, you have the next link and a reference to the element. Right? So you have 2 fields in a singly linked list node, and you've got 3 fields in a doubly linked list node. Okay, so if you were to draw a singly linked list, it looks almost exactly like a node-based stack or queue. Right? The box and the arrow represents the node. Right? So the box, the value in the box, that's the element, or the reference to the element, I guess. Right? The arrow is the link to the next node. Right? In a list, the first node is called the head, the last node is called the tail. Right? There is the notion of an empty list, right? Just like an empty stack or empty queue. Right? So in the empty list, there are no nodes. Right? So the head node is null and the tail node is null. I think I mentioned this when I talked about stacks, or the node-based stacks. But these sort of structures, they're recursive. Right? They have a recursive structure. So every node in a linked list, you can think of that node as being the head node of some other list. Right? So the first node, right, that's the head of the entire list. Right? The second node, right, the one in blue, well, that's the head of the list shown in blue. Right? The third node, right, you can think of that as being the head node of the list shown in purple. And then the fourth node, right, you can think of that as being the head node of the node shown in orange. Right? So remember what the sublist method does. Right? The sublist method returns a sublist of a list. Right? So if I wanted to return the sublist of that entire list starting at the 1, I just return that list there, right? The one shown in blue. Right? That's easy to do. All I have to do is make a head node that points at the second element, right? And return that list. Right? So that's really easy to do. Right? If I wanted the sublist starting at element 2 and going to the end of the list, right? I just make a head node that points at that node and return that list. Right? And similarly with this one, if I want the sublist that starts at element, the 4th element of the list, right? I just make a head node that points at the 4th element of the list and return that list. So sublist becomes really easy to implement in this case. Right? We're not going to do it though. Okay, now because the structure of the list is recursive, it turns out you can write most or all, I don't know if it's all, but you can write many of the linked list algorithms recursively. Right? So for example, if I did not store the number of nodes or the number of elements in the list, right, you can always compute it. right? And you can compute it recursively, right? So how do I compute the size of the list? Well, I just count the number of nodes, right? How do I count the number of nodes? Well, I start at the head node, and I just follow the links, right? Every time I follow a link, I add 1, right? So I can do that recursively. So here's my public size method, right? Inside the size method, I'm just going to call a private recursive method that returns the size of a list, right? So the recursive method takes in a node as an argument, right? So to compute the size of the whole list, I pass in the head of the whole list, right? So now we come down to our recursive method, right? So this method's recursive, so you need a base case, and then you need a recursive case, right? So in the base case, right? So how do you know that you're done, right? So how do you know what the size of a list is if all you have is a reference to the head node, right? Well, if the head node is null, then there's no elements in the list, right? So in that case, I can return 0, right? If the head node's not null, right, then you know there's at least one element in the list, right? You know that the head node, because the head node's not null, so there's at least one node. Right? So there's your 1, right? That's the number of nodes in the list, right? The head node, so that's 1. Now how many other nodes are there in the list? Well, I can just recursively compute that, right? So I recursively call the method passing in the head node of the next list, right? Of the list starting from the next node, right? So recursively compute the size of the remaining list. So once more, 1 for the head node, right? Plus whatever is left starting at the next node, right? And that will compute the size of the list, right? If the head is null, you know that the size is 0, so the base case runs, right? If there's only one node, right? So you only have one element in the list, right? Then head's not null, right? So it's going to return 1 plus head next is going to be null, right? So 1 plus, call the method again, right? Head next is going to be null, so that's going to be null, so you get 0. So the answer will be 1 plus 0, which is 1, right? And so on and so on and so forth, right? And it turns out most of the methods that you would want to implement for a linked list, you can do recursively if you wanted to, right? It turns out you can also do them all iteratively as well, so using a loop. Recursion, but linked lists are often taught to students so that you can practice recursion. Right? I'll just leave it like that. And I think that's it. Yeah. So in the Monday, I guess, we'll start to actually implement this thing. All right. Any questions? All right. Thank you. See you on Monday. You will get an assignment later today. The last assignment comes out. It'll be relatively short because you only have a week to do it.